How do you write rules for an arithmetic sequence? And actually, instead of saying rules, we should say, because I want you guys to get used to it, general term. The general term. For an arithmetic sequence. Now, I like to think of it like a rule because it's, it makes sense. But it's called the general term because it's any term in that sequence. Okay, let's take a look at this one. Now, first you have to know what arithmetic sequence is. Arithmetic sequence has a common difference. A common difference is like the same difference. It means like the same difference from one term to the next term, but they have to be the consecutive terms. So like, what's the common difference between 5 and 10? You add 5, right? So it'll be positive 5. You add 5 again to get to 15. So it's another positive 5. You add 5 again to get to 20. And so our common difference here is 5. And if you have a common difference, then you know it's arithmetic. It's an arithmetic sequence. So we have d equals 5. And then let me introduce you guys to the formula. We're not going to derive it right now. We'll derive it later. A sub n equals a sub 1 plus n minus 1 times d, which is your common difference. There you go. I know you guys are excited about him. You guys love formulas. Now, what does this mean? Like, why is it written like this? Well, I want you guys to take a look at 15, and let's think about him for a second. We have 15, and we started at the first term. How many common differences would we have to add to 5 to get to 15? 2. Right? Don't forget you said that. 2. So if we were looking for a sub 3, which is 15, right there, we would go and we would plug in a sub 1, which is your first term. So we got 5 plus, and then it says n minus 1. What is n minus 1? What is n? N is 3. So we have 3 minus 1. And then we have to multiply it by the common difference, which is 5. 3 minus 1 is 2. And that's where you get the 2 from. That 2 right there. 2. 2. And 2 times 5 is 10. So we have 5 plus 10. And that equals 15. You guys see how that works? Kind of cool. Okay. Now, to actually write our general term for this sequence, let's write it out with the n. So we have a sub n equals 5, because that's our first term right there. And then we have plus n minus 1. You keep the n because this is for the general term. Then we plug in the d, the common difference, times 5, and then we simplify. So we have 5 plus 5n minus 5. We get 5n. A sub n equals 5n. And that should look familiar. You guys remember that on the DNA? Yes? Yes? Some of you guys are thinking like, well, why would I have to do all this stuff, if I can see right away that it's 5n? Oh, sometimes you get ugly dudes like this, and you don't notice them right away. So I want to use the general term for an arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 times d. But in order to use this, I have to have an arithmetic sequence. So is this an arithmetic sequence? I don't know yet. Let's find out. What you do is you take two terms, any two terms. You could pick these two terms, you could pick these two terms, just as long as they're right next to each other, and you find their difference. So we have 11 over 3 minus 10 over 3. That equals 1/3. And then you want to try it with another 2. So let's circle the next 2. So we have 4 minus 11 over 3. Let's do common denominators here. So we have 12 over 3 minus 11 over 3. That equals 1/3. So it looks like we have a common difference. What is our common difference? It is 1/3. Okay, and now we just need one more thing. We need the first term. Do we know what the first term is? 3. Yep, it's 3. It's right there. It's the first term in the sequence. All right, and we plug those in and simplify. That's all you got to do. So we have a sub n equals 3 plus n minus 1 times 1/3. That equals, we'll have 3 plus 1/3 n minus 1/3. 3 minus 1/3, that's 2 and 2/3 plus 1/3 n. Alrighty, there's my rule. That's my answer. Let's see if it works. Let's do the 1, 2, 3, 4th terms. That's a sub 4. Let's see if it works. A sub 4. If it works, we'll get a 4 for a sub 4. So let's plug it in. We get 2 and 2/3 plus 1/3 times, what am I multiplying it by? 4. Okay, so we have equals 2 and 2/3 plus 4 over 3. Let's write 4 over 3 as a mixed number. We would get 1 and 1/3. And then this would be 2 and 1 is 3. And then if you add 2/3 and 1/3, that's another 1. So that's 4. It works! Smiley face. Yay. Now because we have a rule, you could find any number term. Like right here we have 1, 2, 3, 4, 5 terms. You could find, if you wanted to, you could find the 27th term in this sequence. All you need to do is take that 27 and plug it into your n, and that'll be the 27th term. Kind of cool, yeah? Come on, that's cool. Yeah, that's crazy. Alright, so now let's look at this last one. This last one is kind of different. Now, the problem tells us this time that it's an arithmetic sequence. So we have to write a rule for it, write the general term. I said write a rule, but that's the same as saying write the general term for this. And so let's go ahead and write our general term for arithmetic sequences. A sub n equals a sub 1 plus, that's the first term, plus n minus 1 times the common difference. So we need to find the common difference again, and we need to find the first term. This time we're not given the first term. Okay, so how do we go about thinking about this? When you guys think about this, think of it like this. Wait, that shouldn't say 7, that should say 5. Forgot to fix that. So cross up that 7 and put a 5. So because it says it gives me the 5th term, this is how I'm going to think about it. We have 1, 2, 3, 4, 5 terms. So that's a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And we know that the 5th term is 13 and the 2nd term is 7. Now I picked a problem that we can do all this stuff with, but there's some problems where you can't do all this stuff with. So try to understand how we go about finding this. Now I had some students do this part in their head. They would find the common difference right away. Has anybody got it? Yeah, it's 2. It's 2. Why? How does he know it's 2? Because if we add 2 right here, and then add 2 right here, add 2 right there, we will get 13. So we have to add 2 3 times. Okay, but what if you don't see that right away? Well, what you have to do is you have to know what the distance is between 7 to 13. So how do we find the distance? We go 13 minus 7, and that'll give us 6. Okay, and then we have to divide it by how many times we're adding the difference to it. We would add the difference once, twice, and 3 times. And so we're going to divide that by 3. You can get the 3 instead of like if you weren't able to count it, like let's say, this was 2 and this was 15, or not 15, let's make it 105. If you didn't want to count all that, then you could just take the 5 and subtract the 2. That's the 5 there, and that's the 2. And that'll give you the bottom. And so we have 6 divided by 3. That would be 2. and that's our common difference. So we'll put 2 right here. Now we just need the first term. Now there's a really fast way to find the first term for this one, because for this one we're given the second term. So what's the first term if the common difference is 2? Yeah, it's 5. You just have to subtract 2. But let's say you couldn't easily subtract it like that. Let's say there's it was way more complicated than that. This is what you would do. You would take the general form and you start plugging stuff in. Because if we only have one variable, then we could find it. But right now we have 1, 2, 3, 4 variables. Now we know what the d is. We just need to know what the n and the a sub n are so that we can find the first term, the a sub 1. So we pick an a sub n. 7 or 13. Which one do you guys want to do? 7 or 13? 7? Yeah, 7's smaller. He's cuter. Let's pick him. Okay, so we have 7 equals, 7 is my a sub n. 7 equals a sub 1, because that's the one we don't know, plus, and then we have n minus 1. What is n? Do we know what n is?
2.
Well, we know that we picked 7, so the n is 2. Yeah, 2 minus 1. And then we have d, and d is 2, so we put a 2 right there. And then we get crazy. We have 7 equals a sub 1 plus, that becomes a 1. 1 times 2 is 2. A sub 1 equals 5. Okay, so now we have our general term. Just about. Almost done. A sub n equals 5 plus n minus 1 times 2. Is it simplified? No. Can we simplify? Yes. Distribute. We have 5 plus 2n minus 2. That equals 3 plus 2n. A sub n.